Yeah, today we'll discuss about file level permissions in the Linux. So how we can grant permissions. So how we can see what level of permissions we have granted for a specific file or folder level. So here we can see, for example, let me create a file by using touch command. You people already aware about this information, test.txt. So here randomly I have created one file. Whatever the file you want to generate, you can generate. For example, it might be the bash file or python file, whatever it is. So here you don't know what level of permissions having for this specific file. So when you know ls-l, you can see here you can see this is, by using this you can easily understand, okay, what level of permissions this file is having. Okay, here you don't see any kind of the difference because I am the owner and I am the user. That is the reason you won't see any kind of the difference in the file level. But in real time scenario, that this is different completely. So here the file level permissions, how you can track this file level permissions. If it is a folder, you can see it's a directory. D means a directory. That means it's a folder. Again, inside the folder, we have separate files or whatever the files will be available in the folder level. Okay. Here, it's a simple file only, text. After that, we don't have any kind of hierarchy. So here you can see file level permissions. Yeah. Let me take this. Let me show you what is this actually. Yeah. So here just I am splitting to 3 3. Yeah, I have split it to 3 3. So here first one is the users. Okay, second one will be the groups. Okay, third one will be the others. Yeah, I'll explain about this users, groups, and others. So who is the owner, while creating the file he can able to grant the permissions for a specific user. For example, in this use case I am the owner. That is the reason I cannot able to see the difference. In real time scenario, you have logged into one of the instance for yeah, it might be the ec2 instance or some other on-prem server, whatever it is. So here you can see the server instance name. So whatever the account you have logged, you can see here. It might be the sudo or root. So whatever the account you have logged, so you can see here. So which user has developed this? Such kind of information you can see here. These all are the informations. Here users, groups, others means user. A user can have only read and write access. He cannot able to execute this one. That, so this is called uh, user level permissions. Second one, groups. Other groups can able to read the file only, cannot able to execute the file. Next, others. Here also you can see others can able to see the file only. He cannot able to execute the file. This is the intention of users and groups and others. You can see user can have only read and write. He cannot able to execute. Okay, next here he can read only. Groups can read. Others also can read only. I'll show you practically how we can grant the permissions. I'll show here. Okay, so mostly in I mean in programming language, everything will be represented in binary format only. That means every programming language was derived from binary language. It's not system. I mean it's a system defined level language. Here this is representation of the 0, this is representation of the 1. So each binary digit having some kind of the individual value. You can see here 0 means no permissions, so here 1 means execute only. Next 2 means write only. So these are the different level of permissions based on the binary digits. After we concluding all the permissions level, simply we can note down only three level of permissions. First one will be the read, write, execute. You can see here, this is the read and this is the write and this is the execute. I believe you already aware about this binary information. If you want to convert to binary to this octal, just multiply with 2 for each use case with the power of 0. So automatically you will get the respected information. For example, in this use case, okay, 2 power of 0 plus 2 power of 0 plus 2 power of 1, you can see 1. In this use case, same like whatever the binary has been increasing, based on that, based on the position, you can increase the power. Okay, here 2 power of 0 0, 2 power of 1 no. Sorry, yeah, 2 power of 1 no, 1 no, 2 power of 0 again. So based on that we can, okay, here you can see, read we have 4, next to write we have 2, execute we have 1. So here if I want to grant a file level permissions to 754, so this is the one, 4 plus 2 plus 1. That means this is having all permissions. 7 means read, write, execute permissions. I'll show you for the same script. Okay, here 5. 5 means 4 plus 1. 4 means here in our use case 4 will be the read and 1 will be the execute only. 4 plus 1. Next 4. 4 will be the read only. Let me try to grant 754 permissions. You can see, I mean, you can easily understand for specific file. So how you can grant the permissions? You can take the file and simply try to execute this format. Okay, we have granted the permissions to specific file. Here you can see, so color has changed, and along with the previously you can see this one, now you can see difference. Okay, let me take this again. Let me go to the notepad, we can compare. Yeah, now you can see 4 plus 2 plus 1. You can see here, read, write, execute permissions we have. First one you can ignore. First one will be, it might be the directory or anything, it will show. So here 4 plus 2 plus 1, here you can see 4 plus 2 plus 1, read, write, execute permissions. Next 4 plus 1, 4 plus 1 having 4 plus 1, read plus execute permissions. So read plus execute permissions, you can see here. Actually read, write, execute, we have not granted write permissions. 4 plus 1, you can see here, 4 plus 1 will be whatever the permissions you can see here. 4 will be the read and 1, 4 plus 1, read and execute. You can see here, read and execute. Next, last one will be 4. 4 means only read permissions. So you can see here, read permissions. So this is the way we can grant access. Okay, let me show you example. I'm trying to create one other Python file, test.py. Okay, so here insert, I'm trying to enter, sorry, I'm trying to write print statement. Hello. Okay, while I'm trying to execute, automatically it will execute because the file level permissions I have already have. So test.py. So here you can see user can able to write and execute. Sorry, execute don't have. Okay, read and write. Let me check. I am the owner, so probably I believe I can execute because I am the owner. I have super permissions. Yeah, I can able to execute. So what I will do, change my permissions to test.py. Mostly for me it's execute because I have logged with the super user. Let me try. You can see I have granted 444 permissions. 444 means all read only. Here you can see 444 means all read permissions. Only read permissions 444. Let me check. Yeah, in my use case it's executed because I have super user. I have logged with the super user. Irrespective of that, it's executed. But in real time scenario, whatever the file permissions you have granted, based on that only it will be executed. Okay, I am the owner here. In this situation I am the owner. Okay, and I have created the file. That is the reason I can able to run the file irrespective of the permissions. But in real time scenario, it will not be happened. Based on the permissions level only, we can able to execute the file. If file should have to execute mandatory means you have what level of permissions you have granted. It will be purely depending on only the file will be executed. If not, it will not be executed. So this is file level permissions. How you can grant for folder level? Same. Here also same. How we have granted to file level 444. So I am granting to test2 folder. So here you can see previously test2 read write execute and read execute and read execute. Here I am highlighting. Now you can see I have modified everything. This is the way we can grant permissions to file level and folder level. So this is about to file level permissions. So that's all about this video, guys.